Greetings everyone, we are from Group 6. Today, we would like to discuss on a topic which is quadratic least square. In this video, we are going to explain the formula used and solve some of the examples by using both calculator and MATLAB algorithm. Curve fitting is to capture the trend in the data by assigning a single function across the entire range. As we can see from the graph, this is the best curve that represents our data, and different from interpolation, the curve produced might not visit every data point in the graph.
Now we proceed to the first example. Given the following data, if fs equal to as squared plus b, a and b are constant, determine a and b using least square method. So we want to find an equation which minimizes the total least square error. We use the formula s equal to summation of y minus fs bracket square. Since we have 5 sets of data and our I start from 0, so n equal to 4, and we substitute the as squared plus b into the fs and expand it. Then s is minimum if del s over del a equal to 0, so we differentiate s with respect to a, divide by 2, and then expand it and arrange it to get the first equation. Then we proceed with differentiate s with respect to b equal to 0. Then we arrange it to get the second equation. So now we have these two equations. We arrange them into the matrix form. And then we use the calculator to calculate the summation values of s to the power of 4, summation of s squared, summation of s squared y, and summation of y. So these are the answers that we can calculate by using calculator. Then after we get the answer, we substitute it back to the matrix. Then we solve it. And then we will get b equal to 1, a equal to 1, and our final answer is fs equal to s squared plus 1.
To show the example 1 by using MATLAB, firstly we enter the column vector of x, which is 0, 1, 2, 3, and 4. Then we also enter the value of fs, which is represented by y. The values are 1, 2, 5, 10, and 17. Then since there are 5 data in the question, so we can use 5 times 3 matrix. For the first column of matrix A, we put the value of x squared. For the second column of matrix A, we put the value of x. And for the third column of matrix A, we put the value of 1, because when the x equals to 0, the value of fx will be 1. And we can get the value of ABC by using the function of pseudo inverse. Pseudo inverse of matrix A times matrix Y. Pseudo inverse is the inverse of matrix, even though the matrix is not a square matrix. So we can get that our value for A is 1, B is 0, and C is 1, which means that the function is fx equal to 1x squared plus 0x plus 1. So the function will be fx equals to x squared plus 1, where a equals to 1 in our question, and the b in our question equals to 1.
Here is our second example. First, we should derive the equation of s by substituting the equation of yx into it. This is the equation of s. From the question, we know the value of n equal to 5. After that, we differentiate the equation of s with respect to a, b, and c and equal them equal to 0. To get the unknown value inside the matrix form, we can insert the data from the table by using calculator. After getting all the unknown value in the matrix form, we can solve it simultaneously or by using calculator to get the value of A, B, and C. For the final answer, we just substitute the value of A, B, and C into the fx equation.
Okay, here we go. We're going to talk about least square method using MATLAB. Okay, based from this question, we have made this resolution data. These data are collected using formula. So from here, we summarize our results and we get, as you can see here, this is a plotted graph. And you can see the equations written down there. Y equals to 1.0893x squared plus 0.2321x plus 3.5.
Now I'm going to proceed to the formula of quadratic least square. We have data point given by xi, yi, the I starting from 0 until n. X is the independent variable and y is the dependent variable. The quadratic equation can be expressed as y equals to a plus bx plus cx squared, where a, b, and c are the constants to be determined later. The error ei is given by ei equals to yi minus y bracket xi. Y bracket xi we can substitute in by y equals to a plus bx plus cx squared, so that we get the equation of ei equals to yi minus a minus b xi minus c xi squared. To minimize the total least square errors, we need to find the sum of square of the error as s equals to summation bracket yi minus a minus b xi minus c xi square. And then we need to minimize s with respect to a, b, and c. S to be minimum if derivative of s with respect to a equals to 0, derivative of s with respect to b equals to 0, and derivative of s with respect to c equals to 0. From derivative of s with respect to a equals to 0, we can obtain the summation equation of summation from I equals to 0 until n 2 bracket yi minus a minus b xi minus c xi square cross bracket negative 1 cross bracket equals to 0. From the derivative of s with respect to b equals to 0, we can obtain the summation equation of summation from I equals to 0 until n 2 bracket yi minus a minus b xi minus c xi square cross bracket negative xi cross bracket equals to 0. From the derivative of s with respect to c equals to 0, we can get the summation equation of summation from I equals to 0 until n 2 bracket yi minus a minus b xi minus c xi cross bracket negative I square cross bracket equals to 0. We can notice that there is the common coefficient of negative 2 from these three equations. So we divide every equation with negative 2 and then we expand it to get the normal equation. These are the normal equations that we obtained from the previous equation after doing expansion. And then we put these three normal equations into matrix form to form a system to solve A, B, and C. And then we put the value of A, B, and C into the quadratic equation of y equals to a plus bx plus cx squared, so that we can find the sum of square of errors.